Okay, alright, here we go. Wait, never mind, hold on, I need a pack. Okay, alright. So now we're on the second page. This time I think I'm going to do the projectile questions. Alright. I'm going to start with number 9 actually. So can I get this to show up nicely? Alright, a diver, initially moving horizontally with a speed v, dives off the edge of a vertical cliff and lands in the water a distance d from the base of the cliff. How far from the base of the cliff would the diver have landed if the diver initially had been moving horizontally with speed 2v? Alright, that one's kind of confusing. Don't worry, I read it like 5 times before I started solving it. Alright, what are they trying to explain to you? What's the picture for this one look like? The diver basically runs off the cliff. That's his trajectory, right? Initial speed is v. Right, and they say that the diver lands a distance, they land a distance d away from the base of the cliff, right? So another one of those annoying questions with no numbers in it. How far from the base of the cliff would the diver have landed if the diver initially had been moving horizontally with a speed 2v? Alright, so you might think that you need to do some calculations for this, but really you don't. It's a lot simpler than it looks. They put this suspicious looking answer here, right? Can't be determined without knowing the height of the cliff. Well, guess what? If you don't know the height of the cliff, you wouldn't be able to determine the time. Okay, that is true. But luckily, that really doesn't really matter because it's falling the same distance. It's falling the same height in both cases. So it doesn't matter that you're increasing horizontal velocity. It doesn't matter that we can't calculate the time because the time is the same in both cases, right? Our distance, dx is equal to vx times t, right? Or in this case, it's just d is equal to v times t, right? But these are our horizontal variables. If our time is the same, and we just have, we increase our velocity by 2, right? How far away would they land if the diver had been initially moving at a speed of 2v, right? Well, basically we're just multiplying one side of the equation by 2. So obviously the results that you would get on the other side are multiplied by 2 as well, right? There's a simple explanation for everything. Most things. Alright, so your answer is 2D. Right, just like 2D kinematics. What a coincidence. Isn't that neat? They threw a little joke in there just for you. So in the rest of these, let's see. That's not a projectile one. Alright, so let's start with 11. Right? Projectile is right. A projectile is fired with initial velocity. Hold on, I'm shaking this camera. There you go. Can you read that? Yeah, that's good. Alright, a projectile is fired with initial velocity v naught at angle theta naught. Right, so that's what the little O, I don't know if you can see it, let's zoom in. Alright, that's what the little O means. Afterwards, v naught, it just means initial velocity. We've been using vi. Vi, v naught, they both mean the same thing. Don't get confused. Alright, so it's basically the projectile is fired with initial velocity v and angle theta with the horizontal and follows the trajectory shown above. Which of the following pairs of graphs best represent the vertical components of the velocity and the acceleration v and a, respectively? Right? I think I messed that up. Which graph shows the velocity and acceleration? Right? That's it. That's what we're looking for. Okay, well, look at these. I don't know if you can see this on your screen, but the left graph is velocity and the right one is acceleration. Okay? What's the definition of a projectile? It's any object for which the only acting force is gravity. Right? if your only acting force is gravity, then the only acceleration you're going to have is the acceleration due to gravity, right? It can't be anything else. So acceleration is always going to be constant. Okay? And actually, that piece of information right there, that should be enough to narrow it down and figure out the answer, right? We need to have a constant negative acceleration, right? That's the direction of gravity, right? Either 10 meters per second squared, 9.8 meters per second squared, whichever class you're in, whatever value you're using, it's always in the negative direction. It's always constant. So really, that right there, that cancels out every other answer, right? So obviously the answer has to be D, but that's not fun. That was too quick. All right, so let's talk more about this. It's thrown upwards, right? We're throwing it up into the air. We have an object and we are throwing it up, all right? We're throwing it upwards with a positive velocity. So we know that our velocity has to start off positive, right? And if we have acceleration, we know our velocity has to be changing, right? Here we have a graph with a velocity that starts out positive and slowly becomes negative, right? That's exactly what happens. We start off with positive velocity, then once you get to the peak, your y velocity is 0, right? And then you start increasing your velocity in the negative direction. So it's a nice clean diagonal slant, right? That is the correct velocity graph. Our acceleration is constant, right? This is not constant acceleration, so that can't be it, right? Well, this seems to be a popular choice for velocity graphs, but we don't have an increasing acceleration, so that can't be the answer either. Part C says that we have 0 acceleration, also says that our velocity starts off negative and then becomes positive. Right, so that can't be it. And then E says that we have a constant velocity and 0 acceleration. Right? So this is the correct answer. Our object is thrown upwards with a positive velocity. We have a constant negative acceleration, which means we have a constant downward slope the entire time on our velocity, right? It's thrown up into the air. Our velocity becomes smaller and smaller until it reaches the highest point, and then your velocity increases in the negative direction. All right. We're gonna skip 12, and we're gonna take a look at 13 and 14. So we have this nice, neat little diagram here. Right before I even read the question. Oh. Alright, so we're dealing with a projectile that's launched from over here. We have 3 specific points on our parabolic trajectory: P, Q, and R. Ball is thrown and follows the parabolic path shown above. Air friction is negligible. Point Q is the highest point on the path. Points P and R are the same height above the ground. Okay. So the key thing to remember here, before we even read these, before we even figure out what they're asking, all right, I'll tell you right now, if you're at the same height in your trajectory, your velocity is going to have the same, not the same magnitude, well, yes, same magnitude, but the absolute value of your velocity is going to be the same for both of these, right? Let's say if we threw it up, right, even at the bottom, right, most commonly they'll ask you something, what's the end velocity over here? Well, it's just going to be the opposite direction of your initial velocity, right? If we throw it upwards, if our initial y velocity, let's just say if it's 8 meters per second, right? Well, then it will decrease until it reaches 0 meters per second at the top, and then it will increase in the negative direction, right? So that's still a negative acceleration the entire time, but you still have the same rate of acceleration, right? Even though it's in the opposite direction, we're still decreasing our velocity at the same rate, right? Or we're increasing our velocity in the negative direction at the same rate that we decreased it in the positive direction. If that doesn't make sense, all you need to know is at the same height you'll reach the same magnitude, right? So if we throw it up with positive 8 meters per second over here, it'll slow down until it reaches 0 at the top, and then it'll speed up and reach negative 8 meters per second squared at the bottom. All right, so that's exactly what they're going to ask us. How do the speeds of the ball compare at the 3 points, or how do the speeds of the ball at the 3 points compare, right? So when they talk about speed, they're talking They're not being specific. They didn't say y velocity, they didn't say x velocity. Right? If you were to draw the direction of the speeds throughout this trajectory, what was I going to say? I mean, it's not nice and neat, right? They are changing, but you don't need to calculate the speeds. You don't need to calculate the numerical value. They don't even give you any numbers for this, right? It's all conceptual. You're supposed to understand how this works already. We don't know what the y velocities are, and we don't know what the x velocity is. But our x velocity at p, q, and r is always going to be equal, right? X velocity won't change. Only the y velocity changes, right? So because of that, your resultant velocity, really, if we can just look at the y velocities, because where you have the highest resultant velocity, that would also be where you have the highest y velocity, right? I think that's it, right? Wherever you have the lowest y velocity, that's where you're going to have the lowest resultant velocity, right? So really, it's changes in your y velocity are going to cause the changes in your total resultant velocity altogether. But x is always constant. So really, we're only going to be looking at our y velocities here, right? And then the greatest magnitudes, right? The greatest would be at the bottom, right? You're traveling the slowest at the top. So that means, right, Q would have to be the least. So it can't be this answer, it can't be this one, right? Look at that. Just narrowed it down to two choices. Q has to be the lowest, and then we already said at the beginning of this question, we said that P and R, the magnitudes are the same, right? The magnitudes of the velocity are the same. They're not in the same direction, but the numbers would be the same, right? It's just one is positive and one's negative, right? So the speeds, the magnitudes of the velocity would be equal. So your answer for 13 is D. Number 14, which one of the following diagrams best shows the direction of the acceleration of the ball at point P? Right? This is a silly question. This is a waste of time. Right? Acceleration is always downwards. It's always downwards. That's it. That's the end of that question. Right? Nothing else to it.